we are now going to study heat conduction in greater details. So heat conduction is heat transfer through a solid from a region of high temperature to a region of lower temperature by direct contact of matter. So we have a region which has a higher temperature, a region which is lower in temperature, and we place a solid in between these two regions in order for heat to be transferred from one region to another region. So this rod here allows these two regions to be in thermal contact. Now once you have thermal contact, heat can transfer from the hotter region to the colder region. Okay, so we are going to study this specific example, and we are going to set some things to be fixed. One thing that we set as fixed is the temperature of both ends are fixed. So we have a hotter region and a colder region, right? We are going to fix this temperature at these two ends over here. So when we fix it, right, we will call these two places or these two regions here as heat reservoir. Okay, so you can imagine it as if, let's say we set here to be 100 degrees Celsius. So when the heat conduction happens, we want this region here to always stays at 100 degrees Celsius. Okay, on the other hand, on the other end of the rod, let's say we set this at 0 degrees Celsius. And for this specific condition that we are studying, we want this side of the rod to be always 0 degrees Celsius. Okay, so how do you achieve that, right? You can think of it as if you keep boiling water at this end of the rod. So if you are boiling the water, then the temperature maintains at 100 degrees Celsius because that's the boiling point of water. On the other hand, on this region over here, you can place a lot of ice in this region over here. So once the heat arrives in this colder region, the ice will absorb the heat, and in that case, the temperature will maintain at 0 degrees Celsius. Because you put a lot of ice there, once the energy reaches this colder region, it will be absorbed by the ice. So the ice always maintain the temperature at 0 degrees Celsius. Okay, so even though at the hotter region, there's always energy that exits the hotter region to enter the rod. Okay, the rod takes away the energy from the hotter region, but because you are constantly boiling the water, your fire is actually supplying energy to this hotter region to maintain it at 100 degrees Celsius. Okay, so to summarize, the rod takes away energy from the hotter region, but you're applying a fire to keep the temperature to be constant 100 degrees Celsius here. Okay, energy keeps entering the colder region, but because you place a lot of ice there, you absorb away the energy so that the temperature remains at 0. So this is how we maintain the temperature at maintains the temperature at both ends over here. Of course, it's not specific, it must be 100 or 0 over here, it can be any other temperature, but I'm just trying to tell you how we fix the temperature over here. Okay, but that's not really our main concern. Okay, our main concern is how does the energy flows between the hotter region and the colder region. So this is what happens in this rod itself. Okay, so because we set both ends to be fixed in temperature, we can say this end, the left end of the rod, has a fixed temperature, which is this red dot over here, whereas the right end of the rod has another fixed temperature, which is this blue dot over here. So what we are concerned about is how does the temperature varies along the rod. Along the rod, how does the temperature change along the rod between the hot end and the cold end? This is what we are concerned about over here. Okay, what we know happens inside this rod is that there will be heat conduction. So heat conduction means by the particles on the hotter end will vibrate vigorously, and it affects the the neighboring particles to vibrate vigorously as well. And this is the mechanism in which heat is transferred through conduction. Okay, so later we'll be studying in greater details how does this temperature varies along this rod over here.